Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Jeremy McCullough, a senior product engineer, and we're going to continue talking about power energy solutions with smart system sizing. Hey, Jeremy.
Hey, Cully.
So we're going to continue right where we left off. We were talking a little bit about power energy solutions, and we were talking about VFDs, motors, how they fit into a plant, the consumption of energy, power. And you mentioned that SEW can help guide our customers or help them make smart decisions when it comes to selecting these components for an overall solution. So let's just jump right in. What can SEW do to help our customers when it comes to selecting not only motors, but drives, controls, automations, VFDs, the whole package as a smart system sizing kind of solution?
Sure. So one way that I think SEW and the way that I look at it is like whenever you're approaching an application, some customers, they may approach sizing a motor based on like a simple formula, and we even have like little note cards like that we give out like with little simple sizing formulas, to go from torque to horsepower. Or if they use something like PT Pilot back in the day, like they could plug in sort of their application data and then get like a simple motor sizing. However, whenever you select a motor, even though you may be used to picking it based off of horsepower, it's actually a little bit more, or it can be a little bit more, I don't want to say complicated, but there's a little bit more to it because most of the time whenever a motor is rated in terms of torque or horsepower or kilowatts, whatever it may be, that's based on a constant operating point. But the reality is, it doesn't matter what application it is, they're normally not operating at a constant point. Like you have an acceleration phase, you have a constant speed phase, and then you have a deceleration phase. And that's for generally all applications. And so what we try to look at is for an application, like how much torque is needed for the acceleration, how much is needed in constant movement. Does that change? Like, do you have, a machine that's loaded sometimes but unloaded others? Do you have sometimes does it need to run at a slower speed or a faster speed? How much time in between the movements does it take? And so we tend to look at all of that, like we'll size everything based off of the physics. And so instead of just giving you like, hey, here's your 10 horsepower motor, we can actually make a report for your specific application, whether it's a hoist or a storage retrieval system or even a simple conveyor. And we can break down all of those different travel phases. And the reason that we do that is because in most applications, the acceleration has the highest peak demand. And so this is, where we get into power, because you need to accelerate once, but maybe you run at a certain speed for 10 minutes. And so what we do is based on that peak utilization, most motors, even though we rate them for continuous usage, they can actually handle a peak. So if you have a 10 horsepower motor, it doesn't mean that, that's the most that you can ever get. Maybe you need 20 horsepower for the acceleration phase. But that doesn't mean you have to go with the 20 horsepower motor. You can go with a 10 horsepower motor and utilize the overload capacity of that motor. And then you end up with a motor that's sized correctly for the continuous movement, but also able to handle the peak demand. So we look at all of that sort of stuff whenever we help size an application. And all you have to do is give us your application data and we can help with that. And the reason why that's important is because if you have a motor that's oversized for the continuous movement, if you size for peak, like so let's say you needed 20 horsepower for your acceleration, if you make your motor that big, then it means it's not going to run as efficiently. And it's going to be oversized. You're going to oversize your VFD. You're going to oversize, your supply at the grid, and everything's just not going to be, optimized, as well as it could be. And so that's kind of what we help to do at SEW, because we have everything from the gearbox to the motor to the VFD. And then in some cases, the power supplies and modules and things like that. And we want to work with our customers to find a solution that works for them and is efficient and just makes sense.
Yeah, I mean, talking about that peak, I can definitely see how if you're oversizing a motor for the worst case condition, and it's only going to see that for a fraction of a second. I mean, we were talking about power and energy last podcast. I mean, those are the two things that our customers are trying to minimize, and we've already maximized them. And it's not going to be the most efficient system, which I feel like efficiency is a real big buzzword right now. Everyone wants to be efficient. And you were talking about the gear motor, the gearbox, the motor, the VFDs, possibly the controls or power supplies. Is it helpful, and is there a real benefit of using all SEW? So SEW VFDs, cables, motors, and gearboxes? Is there something that we can really lean into with that? Or is this just a general sizing correctly can save you that much when it comes to power and energy?
I think some of the practices and things that we go through to size it, that could be applicable to anybody. But if you go with an all SEW system, then we have all of that data in one place. And so what I've seen, and of course, like we have cases where customers might use our gear motors with a third-party inverter, and that's perfectly fine. It's if that's what's worked for them. But if you have us size everything, then you don't have to like transfer this information and knowledge from one party to the other. It's just all in one place. And for example, our Workbench software, it considers all of that stuff from the gear motor cables, power supply, VFD, all of that sort of stuff in one place. And so you don't have to worry about like one party who makes the motor trying to work with another party who is trying to size the VFD. Like we have all of that sort of knowledge in one location.
And I mean, a one-stop shop is definitely easier for customers to work with. And, sometimes sharing information, we all played telephone as a kid. It's not always the same information that it started off as. So I can see that being a real benefit as well. And we're talking about some of these applications. Is there one that's maybe a good highlight of an application that can really be optimized when it comes to sizing? Or where would we see, a good example of how we want to optimize the power and energy that the customer's using?
I mean, there's a lot of different cases. Like if you're just talking about like optimizing, a standard motor, a simple application, then even just a conveyor. Because if you think about, I don't know, a conveyor in like a distribution center or a baggage system, like, in your airport, like your baggage goes through the conveyors, underneath the building. Most people don't get to see it. It's very interesting. But, and something like that, you typically have an acceleration that happens for a very short period of time, and then that conveyor just runs because it has to get that entire train of bags or whatever it may be, boxes, and it runs for a very long time. And so in those cases, like it makes a lot of sense to spend some extra effort in the sizing to make sure that you're properly utilizing the overload capability. So MoviGear, for example, like that's where MoviGear really shines, is because it has a very high overload capability, and you can end up with a smaller sized motor than you would if you went with like a standard AC induction motor. But you don't have to use a MoviGear. You don't have to use a permanent magnet servo motor. You can use any motor. You just have to kind of look at what makes sense and kind of consider like a holistic, perspective of everything. And that's what I call smart sizing, because efficiency is one thing, but optimization and kind of smart sizing is kind of another. Because efficiency, you kind of get in your head like, oh yeah, I bought a premium efficient motor, but that's only one part of, the story.
Right. So we're handling the simple conveyor or more simplistic conveyor drives. And I'm sure that this would also apply to probably automatic storage retrieval systems, getting into more complex movements. I'm sure we can do something with them as well, right? When it comes to power and energy savings.
Of course, yeah. So storage retrieval systems, and if you're a listener and you're not familiar, this is powering like a lot of distribution centers throughout the U.S., like in all these like nondescript like concrete buildings you pass by on the interstate. A lot of retail, any kind of distribution, a lot of these warehouses are automated, and so you have these gigantic sort of cranes that will automatically pull pallets from shelving without any human intervention. And the way I describe this to somebody who's never heard of it, at least family and friends and things like that, when you go to like a vending machine, like the modern ones, and you have like that row of like all these bottles. I'm not talking about like old fashioned one where it's just, you can't see anything. You just push the button. Where you have like a row of all the drinks and you choose which one you want and you choose it. And then there's this little like robot arm thing that goes directly to the product you want, or maybe a different one. It optimizes, it says, hey, there's 3 Cokes here. I'm going to get this one on the right because that has more in there. So it goes and gets it, and then it delivers it to you. And this is basically exactly what they do, except it's on a much, much larger scale. Like we're talking pallets of product instead of just one 20-ounce bottle or whatever it may be. And so these are great because you don't have to have forklift operators. They can move very quickly, and you can put a lot of product through a distribution center without all of the mess. And it can be computer optimized and all that sort of stuff. However, it takes a lot of energy to move that much mass around because these cranes are very big. They can be anywhere from 30 to 100 feet or maybe even more tall. And then the tracks can be, sometimes even, 500 meters, 1,000 meters, depends on the size of things. And so you're moving all that mass around just to move a small, like a pallet, from one place to the other. And maybe you only need one product off of that pallet or something. And so it makes sense to optimize that in whatever way you can. But in those cases, you have a lot of, it's not quite like a conveyor, like where you have an acceleration and then a very long period of continuous movement and then a deceleration. You can have very short movements. Maybe it needs to go from, if you think of the case of the vending machine where, hey, the product's right next to where you pick it up, it only has a very short movement. Maybe that has to do that. Or maybe it's picking it from the far end of the aisle and going to the far extreme other end. So it just kind of depends. It's very variable. And so the optimization case for that looks very different, but it's still something worth looking into. But in that case, you have, in cases where you may have shorter movements, then you have peak movements, but they end up being more, proportionally. And so there you have to kind of pay attention to all the travel cycles and figure out, on average what the motor is. It's not quite as simple as sizing with a conveyor, but that's also stuff that we're very familiar with and can help size. So that's a more complicated example compared to the conveyor, but that's also where somebody's very concerned about energy, efficiency, because they're doing thousands of movements a day and every inefficiency ends up adding up.
Most definitely. So we're optimizing the simpler side, the more complex side. So we're talking about smart system sizing. Do you have maybe 2 or 3 little things or a little checklist of what you would look for or what you would do to start a smart system sizing procedure? Is it looking at the motor first? Is it looking at a travel diagram? How would we start? What information would a customer give us to kind of get the ball rolling to get a system sized correctly?
Well, we like to work in terms of the application. Okay, so what are you moving? So how much does it weigh? How quickly do you want to get from A to B, wherever that may be? And then also just generally, like, how are the mechanics, designed, because a lift is sized differently than like a conveyor or horizontal application. But basically, what I would tell customers that I'm working with is, hey, whatever you have, just give it to me and I'll let you know what we need to kind of continue on. And so what we would do is, based on what the customers told us about, their application and how quickly they want to move, how much mass, we would kind of build up a set of travel profiles, and then we would start sizing the motor based off of that. But we start with the motor, then we go to the VFD, and then the VFD kind of informs the supply side and all the things that the customer has to take care of on their side.
So we're just going to be talking about good old-fashioned torque and speed. So we're looking at how much we're trying to move and how quickly we need to move it. And from there, we're going to work with our customers to really optimize and smart size a system to make sure we're getting the most out of the power and energy that they're utilizing. Is there anything else that we want to talk about when it comes to SEW with the power and energy solutions and trying to get the best system or best solution for our customers, or have we about covered it?
I think in a general sense, we about covered it, because a lot of this is going to be application specific. And that's kind of the important point, is there's not necessarily like one set of, hard and fast rules to follow. Some things, like to truly optimize, like you need to kind of be familiar with that application type and have the experience. And some of our customers, many of our customers actually have that sort of experience, and then others may not, but it doesn't matter. We can meet them wherever they're at and help come up with what makes the most sense for their application.
So pretty much for our listeners, don't be scared to reach out. Please contact us and we'll happily work with you on a power and energy solution for either a simple or rather complex solution. We appreciate your time today, Jeremy.
Thank you.